Good morning, everyone. Today we're going to do miscellaneous exercise from NCERT. Miscellaneous exercise of NCERT. Question number 1. Two cos pi by 13 into cos 9 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13 equal to 0. Well, let's cross check with the question. Pi by 13, 9 pi by 13, 3 pi by 13 and 5 pi by 13. Right. And as you can see, it's a proof sum. We need to prove that this is equal to 0. Now, I'm going to group the first term, this one. And I'm going to use cos x plus cos y formula. What is cos x plus cos y? 2 cos x plus y by 2 and cos x minus y by 2. So when I use this formula over there, we get, I think it's better we group the next two terms instead of this. So let's group this. Let's group this and apply that. Let's leave the first one as it is. Let's group this and apply this formula over there. So then it's 2 cos pi by 13 cos 9 pi by 13 plus 2 cos 3 pi plus 5 pi, that's 8 pi by 13 by 2, because it's x plus y by 2. X is 3 pi by 13, y is 5 pi by 13 and by 2, so that's why it is. And into cos 3 pi minus 5 pi, that's minus 2 by 13 by 2. So 2 cos pi by 13 into cos 9 pi by 13 plus 2 cos 8 pi by 13 into 2, and we know that cos of minus theta is cos theta, so minus will not come out. This will be cos 2 pi by 13 into 2. 4 times 2. What is remaining now? 2 cos pi by 13 into cos 9 pi by 13 plus 2 cos 4 pi by 13 into cos pi by 13. Now, as you can see, we have cos pi by 13 common, isn't it? Not just that, there is also 2 that is common. So let's take 2 and cos pi by 13 common out. Remaining is cos 9 pi by 13 plus cos 4 pi by 13. Now let us apply the same formula once again. So 2 cos pi by 13 into 2 cos 9 plus 4, which is 13 pi by 13 by 2. So I'm writing it 2 directly here, into cos 9 minus 4, 5 pi by 13 by 2, and that's into 2 here. Now this will take us to 2 cos pi by 13 into 13 get cancelled. So we get cos pi by 2. Let's make this as 4. 4 cos pi by 13 into cos pi by 2 into cos 5 pi by 26. Now, what are we supposed to get? We are supposed to prove this is equal to 0. And we end up by getting this. Now, let's see each and every angle. Here we have cos pi by 2. As you can see, there is a cos pi by 2 here. What is the value of cos pi by 2? Cos pi by 2 is 0, isn't it? And 0 into anything is going to be 0. All the other terms are in multiplication with cos pi by 2. So 0 into anything is going to be 0. Therefore, the answer is 0. The first sum is over. So there it is. This is the second question. The terms are already grouped there. So let's just directly apply the formula. In the first one, we have to use sin x plus sin y. What is sin x plus sin y? 2 sin x plus y by 2 cos x minus y by 2. So that will be applied on this, and this is in the form of, this one is in the form of cos 3x cos x minus cos y. So there we use cos x minus cos y formula, which is minus 2 sin x plus y by 2 and sin x minus y by 2. So once I apply the formula, it will come to a form of 2 sin 3x plus x, that's 4x by 2, and cos 3x minus x 2x by 2 into sin x, which is already there. Now cos x minus cos 3x is minus 2 sin 3x plus x, which is 4x by 2, into sin 3x minus x, which is 2x by 2. And there is a cos x out there. Now let's simplify this. So 2 sin 2x into cos x into sin x, and there's a minus, so plus into minus is minus, right? So 2 sin 2x into sin x into cos x. Now just see what are the terms that we can take out common from this. Well, even otherwise, I think we can take a lot of terms out. We can take, alright, look at this. It's 2 sin x cos x into sin 2x, whereas here it's minus 2 sin x cos x into sin 2x. So that means the entire term get cancelled. So answer is 0. Second one is also over. So the third question, cos x plus cos y the whole square plus sin x minus sin y the whole square equals to 4 cos square x plus y by 2. Let's take the LHS and start applying the formula. I think you all know the formula now, so there is no need to write it down. Directly apply. So 2 cos x plus y by 2 cos x minus y by 2, and there is a square on top of this, and over here sin x minus sin y, which is 2 cos x plus y by 2 into sin x minus y by 2. Only thing that you have to be sure about is the formula. Everything comes out easily after that. So now find out what all can be taken out, but mind you, there is a square. Alright, so if you want, you can square it and then take things common out. So this will become 4 cos square x plus y by 2 cos square x minus y by 2 plus 4 cos square x plus y by 2 into sin square x minus y by 2. Now what all terms that we can take out? We can take out 4 and cos square x by 2, isn't it? Yes. So if I take 4 cos square x plus y by 2 common out, I'll be left with cos square x minus y by 2 plus sin square x minus y by 2. And what is cos square theta plus sin square theta? 1, isn't it? 10 standard trigonometric identities. Cos square a plus sin square a is 1. Cos square theta plus sin square theta is 1. Make sure the theta is same. And here the thetas are same. So therefore this is 1. So we are left with 4 cos square x plus y by 2. So third one is over. Next is the fourth question, but I think My students will be able to do that on their own. Third and fourth are very much similar. So you just apply the right formula in right places, square them out, take the terms common out. I'm sure you'll be able to do it on your own. So I'm not doing the fourth one. So I'm going to the fifth question. So fifth one is sin x plus sin 3x plus sin 5x plus sin 7x equals 4 cos x cos 2x and sin 4x. Right. Now, let's take the LHS, which is sin x, sin 3x plus sin 3x plus sin 5x plus sin 7x. Now, when they give 4 terms, try to group two terms in such a way that you can take something common out. The grouping is a very vital part here. If you're not going to group it properly, then you find yourself in a messed up position. So try to group them in a comfortable manner, like you can take something common out. So I'm going to take sin x and sin 7x as in one bracket plus sin 3x plus sin 5x another bracket. Now when I use the formula that I'm going to use here is sin x plus sin y, and sin x plus sin y is 2 sin x plus y by 2 cos x minus y by 2. So we get 2 sin 8x by 2 into cos 6x by 2 plus again 2 sin 5 plus 3 8x by 2 and cos 2x by 2, which is 2 sin 4x into cos 3x plus 2 sin 4x into cos x. Now I can take 2 sin 4x common out. This is what I said in the beginning. You should group them in such a way that you can take something common out. Now I get cos 3x plus cos x. Let's apply cos x plus cos y form on this. So 2 sin 4x into 2 cos 3x plus x is 4x by 2 into cos x minus, so 3x minus x is 2x by 2. So we get 4 sin 4x into cos 2x into cos x. Let's see whether we able to prove or not. Yes, 4 is there, sin 4x is there, cos 2x is there, and cos x is there. So yes, we proved. So there I am with the sixth question now. Sin 7x plus sin 3x plus sin 9x plus sin 3x divided by cos 7x plus cos 5x plus cos 9x plus cos 3x. I like to check my question once again. So 7593. Yes. 7593 and 75. Yes. Now let's take the LHS, and there are a lot of terms in this, isn't it? So let's break this sum into two parts. I'm choosing the LHS and I'm doing only the numerator right now. Numerator is sin 3x plus sin 5x plus sin 9x plus sin 3x. Let us see whether it works the way as it's given. Like they have already put the bracket in the question. Let's see if we were able to take something out when we group it as it is. What is 7 plus 3? 12. And what is 9 plus 3? That is also 12. So I think you can take 6 common out, 6x common out. So I think let it leave it like that and start applying the formula directly. So sin 7x plus sin 5x becomes 2 sin 12x by 2 into cos 2x by 2 plus 2 sin 12x by 2 into cos 6x by 2. So that means 2 sin 6x into cos x plus 2 sine 6x into cos 3x. Now I can take 2 sine 6x out. Remaining is cos x plus cos 3x. Let's use cos x plus cos y formula on that. So 2 sine 6x into 2 cos 4x by 2 and cos 2x by 2. Now that means 2 sine 6x into 2 cos 2x into cos x. Well, that's all I can do with the numerator, right? Let's just multiply and keep the answer ready. Now 4 sine 6x into cos 2x into cos x. So this is the numerator answer. Now let's do the new denominator. Denominator, as you can see here, this is a denominator. So I'm going to apply it directly. So we get 2 cos 12x by 2 into cos 2x by 2 plus 2 cos in brackets, 2 cos 12x by 2 into cos 6x by 2, which is 2 cos 6x into cos x plus 2 cos 6x into cos 3x. Now we can take 2 cos 6x common out. We'll be left with cos x plus cos 3x. Apply the formula once again. So 2 cos 6x into 2 cos 4x by 2 into cos 2x by 2, which is 2 cos 6x, 4, okay, 4 cos 6x into cos 2x into cos x. Now this one is the numerator and this one is the denominator. Now numerator versus denominator, numerator answer versus the denominator answer, which will give us 4 will get cancelled. All terms get cancelled. Cos 2x will get cancelled. Cos x will get cancelled. 4 will get cancelled. So you will have a sin 6x by cos 6x. What is sin by cos? Tan, isn't it? So we get tan 6x. And I think we proved this also then. Yes, we got tan 6x. So 6th is finished. Now this 7th one. Sin 3x plus sin 2x minus sin x equals 4 sin x into cos x by 2 into cos 3x by 2. Now, so left hand side, we have 3 terms here, sin 3x, sin 2x and minus sin x. Which two should be grouped so that we can take the third one, cause something common out? Well, I think sin 3x and minus sin x should be grouped first. So sin 3x minus sin x plus sin 2x. Rearranging and grouping the terms so that I can take something common out. So I'm using sin x minus sin y formula, which is 2 cos x plus y by 2 into sin x minus y by 2. Right? Right. Into sin 2x. Now this is 2 cos 2x into sin x plus sin 2x. I don't find anything common here, right? But then we can expand sin 2x. What is a sin 2a expansion? Sin 2a is 2 sin a into cos a. So that means sine 2x can be written as 2 sine x into cos x. So 2 cos 2x into sine x plus 2 sine x into cos x. Now 2 is common, sine x is common, take it out, 2 sine x taken out, remaining is cos 2x plus cos x. Now once again cos x plus cos y formula, it's 2 sine x into 2 cos 3x plus y by 2, that is 3x by 2 into cos x minus y by 2, which is x by 2. So we get 4 sine x into cos 3x by 2 into cos x by 2. Let's see whether we are able to prove. Yes, absolutely. We got what we need to get. So I finished 7 sums. Try doing it again. We'll see in the next video. Thank you.